Hello guys, good morning. Do you hear me well?
Hello, morning.
Yes, morning.
One sec, because we have several meetings here. We need to switch things. Let me close. Sorry, Kunal. Okay, much better. Now I'm alone in the room. So, Mo, welcome to the first Make Club. Yay! What is the Make Club? Anyone has idea what this session is going to be about? Make Club, Code Club. Yes, no, yes? No idea.
A makers community, maybe?
Sorry?
A makers community, maybe?
No.
No?
Make Club and like Code Club and Grow Club are gonna be like weekly classes that they're gonna change. First, it's gonna be like Make Club, Make, and like be changing every. So it's Make Club each 2 weeks, and there's gonna be like tooling classes. So first, I think you all remember me. Maybe not. No, because this is all MDev. I only present myself to the pre-course students. Okay, so I'm Eduardo Chamorro. I'm faculty here in the lab together with Santi, Oscar, Josep, that you have already been in contact with. Just as a little bit of context, I'm architect with masters, and now I'm doing also a PhD in specializing into 3D printing, high structural structures for architecture. And I'm gonna be your professor mostly for the hardware part. That's why also the Make Club, as it takes in context, hardware like design, like parameterization, like CAD, CAM, like more or less multitasking. And Oscar is gonna be all the time with you with the coding part of the master. So Make Club is gonna be a tooling class. As a tooling, we call it as digital tooling class, but some part of the class is gonna be with hardware-related hands-on. So to give you an idea, the first club is gonna be intro to parameterization, like CAD, parametric CAD, and we're gonna work mostly with Grasshopper. Grasshopper is gonna be one of the main tools for this course. We're gonna have a few sessions with Grasshoppers. We will also jump more or less in January into robotic arms. Looks cool, no? Yeah, so you will get to touch robotic arms, and we will do a few small projects with them, like painting. We will also 3D print with robotic arms. So you get to know how to use these more specialized tools, the same as you will learn how to 3D print, laser cuts, CNC, molding and casting, composites, etc. Usually it's not part of the curriculum, but we want to introduce because the house has a lot of expertise into robotic, and we want you to play a little bit. You will also have like G-code, that if you don't know, you will know in the future what is G-code. Arduino with Firefly connected to Grasshopper. So it's like how to connect and visualize Arduino data in a 3D CAD environment, mechanism, and more Grasshopper. You will go through physics modeling and parametric modeling, etc., etc., etc. Everybody is excited about? First, you all have already Rhino installed, no? Yes! Okay, I suppose you all have Rhino 6 already installed, and the good point is Grasshopper has Rhino 6 has already Grasshopper embedded by default. So for now on, this page, I'm gonna send you this page in the chat. And I'm gonna also share it in my screen. How I share my screen. Screen 2, share it. Yeah. So the link that I just sent you is basically is where we keep all the documentation for the course of everything and everything we will do through the course, like from like the almost useless machines to like biology part and the future part of from January the Fab Academy adapted part for MDF. We will host all the communication and documents here. This is a live documentation that is updated yearly. So actually here you can already see last year content, all slides last year content. So don't worry at all, because if you go to weekly classes, oh my God, so slow, you have like all the curriculum and the educational content from last year, and we update it yearly. So if you go to the clubs, you have here the schedules, the repositories, and as Oscar explained you with Joseph last week, we will use GitLab to host everything. I think that you have already finished all your web pages, no? Yeah, or you are trying to. So in Make Club, you will find a small repos with robotic arm, Grasshopper 101, Grasshopper class, etc. So if you go to Grasshopper 101 or Grasshopper class, in Grasshopper 101, you will find like what we consider that is like the basic, ultra basic guide that at least you need to learn, understand 10% of it, and read the whole of it. If you just get 10% of this small guide, you will already know like the basics of Grasshopper. This is kind of homework that is a light lecture, reading that you can do whenever you have time. And today's class is going to be on the actually present the program for the ones that have never touched or played with, and start like making some small scripts. Okay, so the methodology for these classes is not that I'm just having a like master lecture, is that you follow me while doing the exercises. So for that we will give time and breaks to actually have time that you find the components, you connect them, and we all get to more or less have the same, reach the same spot that you all completed your geometry by the end of today's class. After the class is finished, just give me a few hours and I will upload the already finished script to the Widget web page. So in case you missed something or you get lost at a point, you will always be able to open the file and check in what point you get lost. So here you have like a lot of script for Grasshopper that right now we are not going to touch any one of them because they are like more advanced. We want to start from the basics. So in this session, can we make pools? I think so, no? Yeah. So I'm going to make a pool. Your few times.
Edu, does Grasshopper come included in Rhino 5?
Sorry?
Does Grasshopper, does it come included in Rhino 5?
Rhino 5? No, you need to install it in Rhino 5. You still have Rhino 5?
Yeah.
Okay, Rhino 5 is like almost nobody keep using it because a lot of the plugins now they don't work anymore for in the Rhino 5 environment. Said that, I still have it installed. I have Rhino 5 and Rhino 6 because some plugins they don't work still in Rhino 6, but 90% of them they all work in Rhino 6, and Rhino 7 is about to be released.
Okay.
And when that happens, like everybody will move out from Rhino 5, the ones that are still using it. Why?
Okay.
Why this?
Edu, can I ask you a question?
Yes.
I usually use Grasshopper in Rhino in Mac. I use it always in Mac. Is it like we have to use it with a bootcamp now, or we can use it still in Mac?
I will recommend to always use the. Wait, why this is not? Sorry, I'm trying to add the question, but I don't know why. Okay, you have a pool. First time we use it, like we enable a lot of things in Zoom that you can vote. So I get to know more or less the level of the class. Launch pooling. Yep. So ideally, Rhino 6, the Mac version, they say it's a full version. I will say it's a beta version. Has like a lot of the features don't work properly. Like there's a lot of plugins that actually you cannot even install. They are only executable files for Windows. You can keep using it for the rest of the course, yes, but there is some parts that you will not able to do at all. For example, in case of the robotic control, we will use plugins to actually produce the files for the robotic arms. They don't, you can't install it into Mac. Happens the same for some mesh topologies, like plugins that are quite interesting. Actually, you get to make really complex things. Also, don't work. For example, like structural analysis also doesn't work. So I think it deserves to have a partition or a bootcamp to actually use it.
Okay. Okay, perfect. I already have it on bootcamp, but perfect. I lose it there. Thank you.
Okay. Okay. Never use, open a few times. Average users, 1. Nobody feels confident to be pro or God level. Good level, sorry. It's missing. It's 2 O's. It's only 1. Give me a second to look for a presentation that I just have it here. Los syllabus experimental day 1, day 2. I'm trying to open. Sorry that I don't have the presentation ready. I just finished a meeting like 5 minutes ago, just before the class. I just have time to went to the restroom. What is this? Oh, you all see my screen, no? No. That's right. It's not. Okay. Perfect. So this is Rhino interface. I hope that most of you know more or less how it works, but we will use Rhino just for visualization. What does that mean? Grasshopper itself, I'm looking for browser, Grasshopper, Rhino. Grasshopper is a parametric program, modeling program. What does that mean? Instead of modeling directly or geometry, what we are doing is setting up conditions and parameters, aka numbers, and small simple equations to define our geometry. So instead of defining a point by locating directly the point in the space, what we're gonna do is use some components. This is a component. It is a small piece of code that actually this is coding. It's called visual scripting because we are coding but without using like the keyboard to type the numbers. We just use pre-assembled pieces of code of script that produce several outputs. What is the simplest one? The simple one will be, for example, a point. How we construct a point? How a point is defined in the space? By 3 coordinates, x, y, z, no? It's the basic, the simplest component ever. So in Rhino, to set up a point, you just, for example, type y cannot point, and you locate your point in the space. But if you want to modify that point, what happens is you can select it and then you can move it. You can move it like randomly, like I'm doing right now, or you can move it a certain distance. But in case that you have like 20 points or a lot of them, what is happening? You want to move all of them, for example, radially, you will need to make a vector. The translation on how to move this is quite complicated. Meanwhile, if this is defined by a number, a coordinate, is really easy to establish rules. So let's first see how to switch on Grasshopper. For the ones that have Rhino 5, you will need to download actually Grasshopper for Rhino 5. Rhino 5. That now I don't know if it's gonna be that easy here. I will put the link in the chat also. Where is the chat? The chat disappeared. Okay. So in Rhino 5, you will not have this icon. You will never see it, even if you install the plugin. But in Rhino 6, you can click here and Grasshopper will open. Another way is to just type Grasshopper. Let's switch it on. Might take a while in my computer because I'm sharing the screen and Zoom eats the resources from the computer and usually goes slower than yours. And I have like millions of plugins also that need to load before launching the program. See, this is normal. You will not should not see an error like that. So you see that I'm having some errors, sometimes it's loading, some pop-ups. Is because there are plugins that are installed that they don't work in Rhino 6, but they work in Rhino 5. Okay. So welcome to Grasshopper. So as you see, it's another window, and most of people, what they do is they put up perspective, workspace at full screen in Rhino, and they move Grasshopper to the right. So they split the screen in half. That is what most people works like. Grasshopper has another workspace, but in here we will never draw any geometry. There are some basic menus like open new document, recent files, special folders, preferences, edit, view, that we will make a configuration, display, and we will say, and I will explain in a second what are different prioritization modes. So let's go to preferences first. In preferences, you want to have enabled autosave. Okay, it's mandatory. I would say it's mandatory unless you have really, really huge scripts. That's why I didn't have it open, like on, because it eats resources and I just need it for the last time I use it. So you should have enabled autosave. You have widgets, palettes. For example, when you preview something, the color of previewing your Grasshopper objects, you can change them here. Like for example, when I don't have my geometry selected, it's red. When I have it selected, it's green. This you can change. Also, not that many things to change. And for example, you can put that the files save with some data about you and some emails in case that you want to share the script and you want that people know who did the script. So right now in Grasshopper, you can see this hovering menu. This hovering menu.
Excuse me.
Yes.
So I've downloaded Rhino. I've downloaded Grasshopper, and I've installed it. Okay. Okay. And now it's saying to have a Grasshopper license agreement. Do I have to open Grasshopper through Rhino?
Grasshopper opens in Rhino. It's a program that works inside Rhino. So to
Okay.
open Grasshopper, you need to have Rhino on, and then you
Open.
switch on Grasshopper on.
Okay.
Grasshopper is a program itself, but works in the Rhino environment. It means uses, like for example, the visualization of Rhino to work, or like and some utilities of Rhino. So it's impossible to have just a Grasshopper working standalone by itself.
Vale.
So most of I will make it bigger. All the tools of Grasshopper are here in this top menu. And you see that they have like a lot of letters, and most of you will finish your menu here. Transform in display, actually. All your menus will finish in display. Why? Hello? Someone had a question? No? Okay. So here is where the plugins that you install will come up. So for example, this is a plugin for solar analysis. This is a plugin to connect Arduino to Grasshopper. This is a plugin to have like complex geometry transformations. In Grasshopper, you can, if you don't see this, wait, preview canvas widget, align compass. You first, let's do a basic configuration of Grasshopper. If you go to display canvas widget, you need to go to have compass, align, mark pop, profiler, and message balloons on. I will say that's mandatory for any Grasshopper usage. You always want to have Gumball activated, preview mesh edges activated, draw icons, and draw fancy wires. So activate everything that you see activated right now. I need to see the chat. Don't have Rhino yet. Okay, the good point is all these sessions are recorded. So you can always check it again.
I have another question. So basically, it doesn't let me open Grasshopper. I tried it to open with Rhino, but it always says it doesn't. Basically, it's not the document Grasshopper could not be opened. Rhinoceros cannot open files in the Rhinoceros document format.
Sorry, could you repeat higher, louder, please?
Yeah, sorry. So basically, it doesn't let me open Grasshopper. So it always gives me the error message. The document cannot be opened. Rhinoceros cannot open files in the Rhinoceros document format.
You have Rhino 6?
Yeah, yeah.
So just pressing this button says that?
Yeah, exactly. So basically, whenever I want to open it. So I'm not...
Yeah, which version of like Rhino 6 do you have?
I have basically version 6.29.
6.29. That's quite new. It should work. Like.
Oh yes, man. Yes. Yes.
Yeah, nice
Jose is el fucking best.
Sorry, I don't know who was speaking, but okay, I will say like uninstall it and reinstall it again. Maybe probably like the installation file like didn't work properly. I don't know if you have an original copy of Rhino. I'm not gonna ask that question, but maybe you want to download another version from the original page. That probably is about the installation. That also, when you kind of install these programs, I recommend to have the installation going only. Don't have like 20 pages of the browser open or trying to install several things at a time. Like maybe the installation is just corrupted. Let's try to solve that on the break. So once you have this activated, we will see that there are several options to put things in Grasshopper. For example, you have right click on the main workspace, will make this menu pop up. Center of the mouse will make this menu pop up too. So for example, let's put a point. There are several ways of putting components in Grasshopper. One is looking for the component itself. Like for example, I can go to point, and this is a point. I'm gonna switch on a plugin that works for explaining you the names, that is bifocals. This is a plugin that you can install and it will show up the text of the component on the top. It's quite useful.
Edu, so sorry, could you repeat the things we had to have activated?
Yes,
So
this one, draw icons, draw fancy wires, preview mesh edges, gumball, canvas widget, all of them.
okay, and they're all activated.
Yes, activated.
And Edu, can you repeat the name of the plugin?
As was going to.
Okay.
So the plugins, most of the plugins are downloaded in Food for Rhino. So basically this is a database of plugins for Grasshopper and Rhino. So let's look for the plugin. This, you don't need to install it. This is, I have installed so you can actually see the panels so you can follow me easily. So bifocals, and you go to bifocals. You need to log in, just have a account. It's free, like most of the plugins are free. All the plugins that we will use are free, okay, for the future. There are some plugins that you can pay, but that's weird. So for example, you download the plugin, and next session I will explain you how to install plugins. In case this one, for example, this plugin is a executable. So this one is really easy to install it. You can download the executable, or this one that is a GH file. GH files are installed in a different way. So, okay, I will explain it just now, how to install a plugin, because it's a really basic thing that you need to do. So bifocals is a file that is usually green. Sometimes there is a compound of files that are green and orange. So you save the file, you look for the file online on your folder, for example, I have it here, and you need to paste the plugin somewhere. So if you go to File, Special Folders, you can see Component folder, Setting folder, User Object folder, and Autosave folder. So Autosave folder is quite obvious. Settings folder is also quite obvious, but we have component folders. That is a window folder. In your case, it should be almost empty. And we have user object folder that in most of the times it says .gh user. So in order to paste or to install a plugin in Grasshopper, you will have the plugin here. For example, I have it in downloads, and what you do is just drag it into this folder. In case that is a gh.user file, you just load it into the other folder. So you have gh user folder, files, and gha. Gha goes into the standard special components folder, like components folder. When that is done, and you have copied your files inside, you need to restart Rhino and Grasshopper. In order to make it work, you need to close Grasshopper, close Rhino, and open again Rhino and open again Grasshopper. They don't load in live. You need to load them, close Rhino and Grasshopper, and open it again.
Wait, so you put in the component folder or user object?
In the component folder, because you need to look at the extensions.
Vale,
Do you see the extensions in your computer?
yes.
Okay. The guys that don't see the extensions in the computer, you need in Windows, in any folder of Windows, you go to View, and you need to have click File Name Extensions. I will say that this is mandatory for now on for the rest of the course, not only for these classes, but for any coding classes. It's really important that you get to see all the time the extensions of the file. Yes?
Yes.
Okay. So, as I was stating, we can put some components from here. For example, we have the parameters, mathematics, that are simple, more sometimes it's not that simple. We have operators like absolute, addition, division, subtraction, domains, polynomials, scripting, trigonometry, mathematical equations. We have sets, that this is for working with data sets. We will see what is that in the next sessions. We have vectors. For example, here we can define a vector, a plane, a point. We can define curves, and you can see we can have like million of types of curves. And for each one of the components, it's always divided in like this. You have analysis. It means you can analyze a geometry. Second, you have a transformation of the geometry. It means breaking up that geometry into smaller components. What is the smaller component, geometrically speaking, of a curve? A curve is defined by a series of points. So we can divide a curve into points. That is the smaller unit. What is the smaller unit of a point? A number. 3 numbers compose a point. A line is defined a minimum as 2 points. What is the next element after a curve or a line? Is a surface. What is the next element after a surface? Is a volume. What is the next element after a volume? It could be a cloud of volumes that creates intersections. We have also how to create primitive curves or lines. We have to create more special kind of lines like interpolated curves, and we have utilities to actually transform those curves. And we have the kind of workflow, analyze, division, primitive, slightly more complex, and transformations for all kind of geometries. On surfaces, we have again the same, freeform, primitive, and utility. For meshes, we have the same. Analyze, this is a plugin, primitive, more complex meshes, and utilities for meshes. And we have in mathematical intersection of geometries, transformation tools, and display options. So in case we want to draw a point, you can take a component, for example, and drop it. I will erase it because now I want to just make a point. A point is one of the singlest element. So it's in params or in vector, point, construct point. But sometimes this is quite annoying to look for the components because there are a lot of components. Imagine if I need to look for a specific component in this list of elements, of plugins. What you do is you look for the search engine. You double click on the workspace, left double click. You can look for point. And it will start showing the different kinds of elements that are with the name point. So, for example, we can, let's say we want to construct a point. So it's construct point. You select it and the component appears. Okay, I will erase. I have already one. You see this component is orange and this component is gray. Everybody is following until now? Up to now?
Yes.
Yes?
Yes, yes.
So orange means the component is not working properly. Something happened. Most of times is missing some data. And it's important that I say not is missing a point, is data. What is missing? If you zoom in the little balloon, you see floating parameter PT failed to collect data. But this one is a point and it's working. Why? Okay, when you select, you see that we have a small cross here right now. No, you see the cross? When I click on construct point, you see it changes the color because I'm selecting the point. But when I click in this one, nothing happens. Why? In Grasshopper, there are two main differences and ways to create simple geometries and establish simpler geometries. One is constructing the geometry in Grasshopper. For example, we are constructing a point in Grasshopper based on X, Y, and Z coordinates. And if you hover over the elements, you can see I can have a 0 value here. No? The Y is also 0. The Z is 0. So a lot of components in Grasshopper, they have embedded values by defect. It means if you construct a point, by defect, it's going to be in the point 0, 0, 0. And if you hover on the right, that is the exit, it says the constructed point 0, 0, 0. So it's in the coordinates. But if I hover over this one, it says empty point parameter. Why? Black hexagonal components are reference components. They don't create geometry by themselves. What does that mean? That this component is empty, doesn't have or construct any geometry as this one. So this component can only reference points. For example, if I connect, this is what easily will become in your computers a spaghetti. So if you click and drag, you will see this spaghetti coming up, and it has like a magnet that put in place. So if you lift, now my construct point is connected to my point. So this one now has a value. Before it didn't have a value. Let's disconnect it. How to disconnect? Control and you click. You need to hold control, meanwhile you click and you see that the little arrow is red and it says negative. If I click shift, it's add another one. But I want to disconnect it, that is control. You hold it and you disconnect. This is quite important. Learning how to connect, that is just drag and connect. Disconnect is control, hold control and click to disconnect. So now this component is empty again. Why? It has literally no geometry. So hexagonal components are useful to be a bypass, or the most common use is to be a reference from something that is in the Rhino workspace. For example, let's draw a point in Rhino. Point, and I have a point that I can move in the Rhino workspace. Yes? So let's say I want to put this point in Grasshopper. How you do it? You cannot use this construct point because it's meant to use values. But we can use this one, hexagonal components that are reference components. So what we can do is select it, right click, and we have a lot of options. We have preview, enable, bake, etc. But we want to set a point. We want to select a point from the Rhino workspace. So now we can select the point, and now the point is in Grasshopper. So we have it as an external reference. Yes?
Yes, but I
Okay.
can't get it to disconnect.
Sorry?
I cannot get the point to disconnect as you.
It's with command in Mac, by the way.
Ah, okay, okay. Thank you.
Yeah, okay. So let's use a component that is your best friend. I recommend it strongly to use every time you have a doubt. That is a panel. A panel is as simple as basically a sticky note to show the information that is inside the components. So for example, you can connect and it's showing you that, okay, you have a reference point. You can double click, put a panel here, and you see that this point is the point 0, 0, 0. So we use panels to show information or to give information. Yes? Let's move these two. So what's the difference between this point and this point? First, this point doesn't exist in Grasshopper. It exists in Rhino. And it gets updated all the time. I move it, gets updated into Grasshopper. This point only exists in Grasshopper. But we can see in Rhino, but it doesn't exist. We only visualize it. We cannot take it and drag it. Let's say we want to move the point. We want to have another position. Let's say I want to have the point 10, 10, 10. We need to input data or a number. There are two main ways to do this. One is use a panel. You double click, you say 10, and you connect. Now you have seen the point has moved. It's in the point 10, 0, 0. And you need to be really careful with something. It's really common that you type your name, your number, and you click enter. And you click out. What is happening? Any idea? So right now, if you double click again, I have this number and I have an empty space. Emptiness is let's say, is an empty value. So mathematically speaking, it's not a 0, but it's a value that has no value. So this component is trying to also use this empty space to create a point. What happened? It cannot create a point from an empty space. So it gives the error. So it's important that you don't click enter and click out. How to see really easily that you have committed this mistake? The panels can show things as a list. So this is a single panel, but we can say it in a different way. If you right click, you see here multi-line data. It's an option to actually show you different numbers. So right now we see that the enter, the space, jump line has created a 10 and an empty number. This empty number is what is making our constructed point fail. And you see now this is creating a point and a null. Null means not valid. So we can double click, erase the jump line, and it will work. There is another component that we always use to create numbers. That is a slider. You can type slider, number slider, and this shows up. So basically this is a slider to be able to change numbers really easily all the time. What happened with this slider? This slider is between 0 and 1. The values are really small. Let's say I want a slider between 0 and 50 without decimals. You need to change it. How you can change it? Right click and you see edit. And this is the slider configuration. So here you can choose if you want floating numbers, integer numbers, like not with decimals, not decimals, even or odd numbers. You can choose different things. For example, I want to have, I don't know, floating number, it means with decimals, but I only want to have one decimal. I want that the minimum value of my slider is 0 and the maximum to be, for example, 50. I click on the green one and you confirm. So now my slider is between 0 and 50. Just drag the slider and you will be able to change it. It's a variable number. So we can connect this one to y and easily we can change the position of the point because we have a moving slider that we can easily change it. Yes? Okay. So what we can do, before going to creating more geometries, I want to show you these kind of things that are here. First is I want to create a geometry because we need to create a more complex geometry. Let's draw a box rectangle. No, sorry, box rectangle, no. Let's do center box. Center box. And let's connect a slider. There is a different way to create sliders. Instead of typing slider and selecting number slider and then go and right click to edit the values, there is a simple way. If you just type, for example, 100 in the look search keyword, just type 100, it will create a slider between 0 and 100. It's a fast way to create sliders.
If we type 100.00, it will have 2 decimals.
Look.
Okay, all right.
Yes. And for example, this is a round number in 100. But let's say you want to create one that is 50. What it will do, it always takes the first multiplier of 10. So if you put 50, the slider will be between 0 and 100. If you put 5, it will be between 0 and 10. If you put 500, it will be between 0 and 1000. And it will put the number exactly in the middle, because well, in your number. For example, if I type 49, my slider is in 49, and the upper limit is in 100, and the lower limit is in 0. So it's a fast way to create the sliders. So let's connect it to center box. We can connect multiple things in one. So now when I select center box, you see the color changes. And I can see that here we have one point and here we have the other point. Let me move this a little bit. Yeah. So I can select one point, the other point, and the other point, and they become green. I can select several things together. What happens if I only want to see this point? I want to hide the other components. We can hide individually or we can hide by selection. This top right menu has different tools. And we can see we have this one, and this one is one menu. Green and orange is another menu. And we have this that is preview mesh quality. This is visualization quality. Like lower quality usually goes faster than higher quality, but you see it works. But we have like the green cylinder. Green cylinder is something that confuses a lot of people. So right now it's deactivated. If you click on it, everything has disappeared. I mean, it's hidden. The program is still calculating all these geometries, but we don't see them. We only see them if we select the component. So the green cylinder will be as only show what I have selected. And it's quite important when your script becomes big and huge and you have tons of components and you only want to see the final result or a few parts. So activating the green cylinder will only show what you have selected. I say that it's confusing because a lot of people, they say, oh, my Grasshopper is not working, you're not previewing anything. No, like you just activated the green cylinder. You can activate it and disactivate it. And we have this cylinder, like the non-cylinder, half wireframe, and the full cylinder. So basically it just jumps between different visualizations. One is wireframe visualization, and the other one is like full surface visualization. Most people just stays with the full visualization. This is overall settings of visualization of the whole script that you have. But let's say that you want to hide or lock or disable a component. For example, if I click in construct point, let's say I don't want to see the center box, but I still want to see this. I can either just have all the time selected this, but this will not allow me to move freely. So I just want to hide center box always. What I can do is right click and click preview. And you see the component now is dark gray. When the component is dark gray, it means the component is running, is still there, the computer is calculating it. If I connect a panel, I can see that the component is still working, but I don't see it. You can right click and enable it again, like preview it again. And I'm not saying enable it, I'm saying preview. Because there is another option that is enable, disable. What does that mean? If you disable the component, right now this component has a input data coming through the component, creating the box and outputting a box. If you disable it, the component is off. It means this component is not working anymore. So it's not creating the geometry. And it's quite important because if you have something else connected on the right of the component, there is no data. And we can see through the line, you see that the wire, the spaghetti, now is orange. Why? It's basically stating there is no information, no data in this line. For example, let's switch it on. What happens if you construct a point, but you disable the slider? You can't construct a point if you don't provide information for the Y. It's not working. That's important to understand what disable produces. Not only disables the component by itself, but also everything that is connected after it. And you are saying, okay, why I want to disable something? Maybe because you're not using it right now, or you want to use it later, and you don't want to use the resources of your computer. In this case, this is just a dot, a point. But sometimes this is a super complex geometry that actually takes time to calculate it by a computer. And we have something that is the profiler, that right now is Canvas widget on profiler. Let me open a sketch so you can actually see what does profiler means. Form finding topological example. Okay, you see this component, for example, here has a little number. What this number means is the time that this component takes to calculate. So just producing this geometry takes 49 milliseconds. It's not a lot, but some components are really resource consuming. For example, well, this case is not a lot. Let me open another document. So for example, calculate this geometry takes 150 milliseconds. If I just change the slider, now it takes 300 milliseconds, and now it's gonna take easily like 2.2 seconds. So my computer is frozen every minute for 2.2 seconds because it needs to calculate this geometry. So sometimes you're working in other stuff and you don't want that the computer is going slow because of this component. So what you can do is disable it. So now the computer goes fast. I can zoom in and out really fastly. And I haven't erased my geometry. I'm just not using it. So now I just enable it and it takes 3 seconds to calculate. So Profiler, the thing that we just activated here, is telling us the amount of time it takes to calculate these components. Why we don't see it now? Because these components are so fast that it's not showing us the time that it's taking, because it's super simple to calculate a point. But in the moment you make more complex geometries, the profiler will automatically show you the time that it takes to calculate. Let's switch on again this, okay? We have gone through preview, enable, and we are missing what? Bake. Bake, the fried egg, basically is what it's gonna do is transform this geometry, whatever you have selected, and make it happen in Rhino. So when you bake, what you are doing is producing the geometry in Rhino. So I can put it in any layer. For example, I can put it in the layer by default. So now I have the geometry in Rhino. But once the geometry is in Rhino, it's just in Rhino. Let's change the workspace. So this geometry is in Rhino. I can move it away, but that doesn't mean that this component, that the geometry I'm baking, is referenced in Grasshopper. This is a one-way workflow. When you bake, this box is not anymore in Grasshopper. It just only exists in Rhino. So let's say you finish your geometry and you want to 3D print it. You have made a geometry, you have made this awesome cube and exists in Grasshopper. But in order to save it to a format for 3D printing, or you want to save just the Rhino file of the geometry, you need to make it happen and make it exist in Grasshopper. So the way how to do it is baking. So when you bake, you have the geometry in Rhino, and you still have the same geometry of the Grasshopper. So now, for example, I can change, and as you see, my component is not referenced. So it's a one way. You usually bake when you finish what you were doing. Important, really important, saving. Grasshopper autosaves all the time. It's constantly autosaving. We can see it on the bottom. Autosave complete 160 seconds ago. And usually each time you put a component, it saves when you have like more than 2 components. I have deactivated, I think, that part. Let me check. Yeah, I have deactivated on object added event, etc. But it saves like most of the times. So it's really difficult to lose a file in Grasshopper. But for making it able to save, you need to have saved at least once your file. If you never save your file, let's say you start a file and you didn't save at any point, the autosave will never work. So in order to make it work, the autosave, you need to have saved the file at least once. So I'm going to save this as the test file. So now the autosave is going to start happening once and again. So if my computer crashes, that happens a lot with Grasshopper because you misconnected something, this will allow you to not lose the file. This file will be saved correctly right now. Yes and no. Why? This file contains information created in Rhino, in Grasshopper, information created in Grasshopper, and information created in Rhino. So this point only exists in Grasshopper. I'm taking an external reference. In order to save this point, I also need to save my Rhino file. So if you are referencing points from Rhino to Grasshopper, you also need to save your Rhino file. You need to save both Rhino and Grasshopper file if you want to keep this point that is existing here. Maybe you don't care, but let's say if I switch off, I make a new file, for example, in Rhino, millimeters. You see, my point disappeared, doesn't exist anymore. I need to create another point in this new file to have it as a reference for the Grasshopper. Set one point. Now I have again a point, but it was not the same point as before. I just created a random new point. So if you want to keep this point exactly in this location, you need to also save the Rhino file.
Edu,
There is another option. Yes?
Sorry, if you internalize the data, would that be
Yes.
okay?
Is what I'm going to explain now.
Okay. Thank you.
There is another option that is internalize the data. That if you right click on the component, you can click internalize data. It's like save this point in Grasshopper. But internalizing data is like freezing the point in this instant. If you do it, the point now is exactly here. But now, if I move the point, it's not anymore referenced. I just froze the point in this moment. So it's not anymore a reference, but the point still exists here. So let's say you want to update to the new location. What you need to do is clear the data, make it empty, and set the point again. So now the point is referenced. So usually you internalize data when you want to close the computer and you want still to keep the points, and you know that you are not going to move that point. I'm just speaking of a point right now, but it could be a geometry, a line, a curve, or whatever. If you know that you still want to move some geometry in Rhino, what you do is you save the Grasshopper and you save the Rhino file. You need to save both. Everybody's following up to here?
Yep.
Yes.
I know this first session is quite boring and it's explaining a lot of methodologies. It's not about creating fancy things, but it's important to understand these small tools. So, for example, let's erase and let's keep only with these 2 points. What we can do with 2 points? We can create a line. Which is the component we want to create? This one or next one? If you hover over the components, you can see that line is saying create a line between 2 points. So it's the component that we want to use. This component, again, is the same as point. It's a reference. We need to, for example, draw a line between 2 points, and we can take as reference. It's exactly the same as, well, actually, this component, you need to draw it manually. It's not taking references. But it works the same. You draw a line in Grasshopper, and you reference it. In this case, what you do is work with components. For example, you connect this point, you connect this point, and I have created my line. So you can easily change it. For example, you can change the grasshopper point, but this point I cannot change it. So it has half-half reference. Half of it is in grasshopper, half of it is in Rhino. Could you do both with just construct point? Yes, of course. The component line is in curve, primitive, line also. And here we can say that we can fit a line between a collection of points, like what happens if we have like multiple points, or we can also interpolate a line or create a polyline in case we have more than one point. What happened? Let's create another point. Let's create 3 points. Point, construct, point. I want to have a point. One way to create sliders is, as I said before, is type slider and change the number, or just state the number, for example, 45. What happens if I want to copy my slider? You can hold Alt key and drag the component. Sorry, drag and hold Alt key is the opposite. I always make the mistake while explaining it. So you start dragging the component and you click Alt, it will make a copy of the component. So it's quite useful. So I can connect, for example, these points here. I can create a point just like this. What happens if I want to make a polyline? Let's try. Polyline. You see, it's looking for vertices. It means looking for points. How you connect multiple points, these 3 points, into this component. There are several ways of doing it. First, you drag the first point, okay? And then you hold the next point and you connect it. Oh, what happened? It disconnected the previous one. I will try it. Oh, it gets disconnected. So in order to correct several things to just one component, the same as to disconnect, we hold Control or Command, I think in Mac, you hold Shift to connect several components into just one element. Because you see that green arrow transformed from a white arrow to a green arrow with a plus. It means we can connect multiple components at once. Yes? No?
Bueno, más o menos.
Okay. We'll do it again. So it's also important the order that you connect. So in order to disconnect, hold Control and drag the line. It will disconnect the components. In order to connect, the first one you don't need to hold anything, but the second one you need to hold Shift. So you see now the curve is different. Now I have a triangle. Why? The order of connecting the points matter and matter a lot. Why? Which one I have connected first? This one. Which one I have connected second? This one. So it's drawing the line from here to here and to here. And I have the other line that is this one. I can hide it. I can right click, enable it, or you can space, and hide it. It's the same. We'll erase a few parts that we don't need now. Okay. So we have 3 points. And it's important that the order of connection matters a lot because this is a list of points. Why? Let's do this in a different way. Instead of connecting like this, let's connect it with a merge component. Merge is basically is a component that allows us to join data. So we can easily change it, and you see that each time I'm connecting, a new one pops out because it's to connect the next one. So I connect a panel here. I can see that I have a list of elements. What elements do I have? I have D1, D2, D3. Point, reference point, the point that I have constructed, and the third point that I have constructed. And I can see that the values change it all the time. So like this, we can easily change the order of connection. And you see the order matters. Why? Because depending on the order of the points, the line is going to be constructed in a different way. If now I change the reference point, that is this one, to be the middle value, now this point is in the middle of the line. So here is when we introduce what in Grasshopper we call data, in data lists. In Grasshopper, we always work with data lists. Instead of connecting 20 points into one component, we kind of stack data in a list. And it's quite important to understand this.
Edu, I know this might be a very basic question, but like,
There is no basic question.
Bueno, what is the point of Grasshopper?
What is the point of Grasshopper?
Like, what's the function? Like, what are we achieving here?
Okay, no, good question. So imagine, okay, I will show you one example. My focus. How it's called is the Holocaust Monumento Berlin. You know this, for example, this space in Berlin?
Yeah.
It's the Holocaust Museum. So basically, it's a lot of stone blocks. Each one has a different size and has a different location. This is, for example, this is architectural application. It could be like there are millions of applications. I usually use Grasshopper not for this application. So basically, this is a matrix of blocks, concrete blocks, located at a certain distance, all of them. No.
Yep.
Imagine that you need to, for producing this object, this design, you need to draw it. No, like usually, like because this is not really old, it was drawn in a computer. Imagine that you need to change. You realize that your model is wrong, and when you were in the site, the space is like 2 meters smaller, and now you need to change all the spacing between the blocks to be 1 centimeter smaller. You need to change all the blocks one by one in the 3D model. That takes years to do it.
Yep.
If you have a full 3D model. Making this parametric in Grasshopper is so easy. It's next level of easy. It takes literally 30 seconds. So why? Imagine that you have this line, but now you want to adapt it. You move the slider and you can easily adapt it. And this is a line. But imagine this in a higher context. For example, this Holocaust Museum, what is made of? It's blocks in an array, no? Okay, so for example, let's go to array, rectangular array. What is the geometry you want to array? A center box. What is the size of my box? I don't know, like 20 by 20, and the height is like 15. This is my block. I want to array my geometry, and I want to have the cell. It means the spacing between the array. Right now, for example, you see I have a lot of components, but the cell is small. It's not okay. So I'm gonna make a cell. Let me look for the component. Sorry. Why doesn't it work? Here. No. Here. cell. So it's a rectangle. I know that I want the elements located at, they measure 20, and I want that the space between them is half of this size. So if the component, the square is, let's switch off this. If the component is 20 by 20, I want that the spacing between two of them is always half. So I have this number that is the master because it's telling me the size of my box. I can divide it, division. Divide it because I want that the space is always half. I can divide it by 2. So I'm making rules all the time. So now I have 10 and I can make an addition. So the space is the size of my block plus 10, half of it. So it's 30 by 30. And this is the spacing. Let's see. Actually, it's not working well. So instead of addition, I will make a multiplication. Double the size. I will erase this and this just to make it easy. So I want that the space is always double the size. Now, you see, it's not still working. So I will make another rule, change the rule. Okay. Or maybe instead of putting a panel, I would put a slider, 3.5. Okay, now I have my elements. I want to have how many elements? Maybe I want to have 200 here in X and 123 in Y. You see now this has shown up what? The profiler is taking 130 milliseconds. I have a lot of files open on the back. To show you, I opened several files. Here, on the top right, you can see that they have like the other files open. So one thing that is important in Grasshopper is try to not have too many files open on the back, and especially files that take a lot of time to calculate. So I will switch off, close the files. I don't want to save them. So now let's move. Actually, this is a matrix of so many squares. I will reduce it just for the sake of going fast by 50. And this is still a lot. So I have my matrix. I can just change the spacing between all of them, or let's say I change the dimension of the block. In the flip of a number and everything adapts. The relation of the space and the size of the block is a steep relation. It's a 3.5 times of spacing of the dimension of the block. So imagine that you just need to introduce a change that your block needs to be 1 centimeter bigger. Doing it manually, it will be awfully a lot of work. But do it in Grasshopper, look, the size of the component, the length of the script we did. It's super small.
That's very clear, actually. That helps.
It's clear?
Yeah.
Okay.
Just to, like, the question, I don't know, the rectangle part in the middle.
Yes.
What does that, is that for the gap between the?
Exactly. This is the gap.
See?
We can see it here.
Okay. Cool.
You see why it's important the on-off, because this was bothering me. So we can see this the space between the center of each geometry. And here in cell, it says rectangular array cell. So it's showing us the spacings.
Cool.
For example, let's say now each block is even, no? Has the same height. Okay, for example, I know I have how many boxes. Let's put a panel and see it. And actually we'll see there is so many. If I hover, it says 1,500 boxes. I want that each one of them has a different height. So I will measure the amount of boxes. We have 1,500. and I want to create randoms for scaling, random numbers. This is a super randomizer, like number of random values. Okay, now I have created 1000 random values, and I want to scale the sets of all of them. Scale non-uniform, just the set. Scaling factor. I connect them here. Center. I found the center of each one. This is, we will do these examples next day. So, but just want to show it fast. And I want to scale my geometries. And now we can switch off everything, and we can see that all the blocks have their own custom scale on the set. Imagine doing this one by one. That, for example, this is the clearest example of parameterization.
How do you make a panel again? You right click?
Sorry?
How do you make a panel again?
Sorry, I hear you really far away, like under the sea.
How do you make a panel again?
A panel. There's two ways of making a panel. Double click and look for panel, or slash slash. Both ways works in the same way.
So Eduardo, this is super powerful, and it's incredible that you were able to recreate the Berlin Monument in like 5 minutes. I was wondering, I imagine when you have bigger projects, those workspaces in Grasshopper, it's like a spaghetti soup, right? Like you were saying.
Yes.
Is there a way to
avoid it? Yeah.
Write a script for all this stuff instead of having the graphic spaghetti interface?
So we have a coder here, no? Yes, you can. One of the good points of Grasshopper is that this is scripting, and this visual scripting. What is the equation of, for example, a sphere? The mathematical equation of a sphere, I don't remember because I'm not that smart, I'm sorry. Like mathematical expression sphere. Okay. But it's this one. When you put the component of a sphere, it's doing exactly this to define the sphere. What happened is doing in a graphic way. There are two ways of scripting in Grasshopper. First is you go to, I never use this component. I always type directly everything. So you can say expression, and you can type here your equation. And let's say you need more components. For example, I can type x per y. This is already an expression by itself, and it's saying what? Left-hand operator is null. It means my data is null. So, for example, I can put a 2 and a 2. So now the result is a 4. This is the same as multiplication, as this one, but I just did as an expression. Here, you can put the expression, any mathematical expression that you want. What happened, for example, if you want to introduce, let's say, scripting, like proper coding. In Grasshopper, you can introduce literally Python scripts and C# scripts too. So you can create a component that is called a C# and Python. You double click, and they open up like the traditional writing code windows. So basically, this is saving a small file, Python file or C# file inside Grasshopper, so you can execute your own custom small pieces of scripts. And basically, for example, most of the plugins, for example, this one I know because this one they write in C#. This is not defined as a expression. It's a C# script just put in a fancy way. But the core on how to run this is a C#. and there is a lot of people that write the plugins, and most of the plugins of Grasshopper is just people that is smart enough to know like heavily coding and produce the custom components to produce what they want, and after they share it. So Food for Rhino works as a database of people. Food for Rhino, I don't know what is Food for Rhino. Yeah, Food for Rhino is a database of people sharing their own scripts. So plugins, most of them, when they are published, it means they work well enough, but sometimes they are bugged or they are not efficient because it's people writing them. And one of the powerful things of why we teach here Grasshopper is the community that is behind hosting Grasshopper. That is actually huge. For example, Dynamo. Dynamo is the parametric version of this from Autodesk. Dynamo Autodesk. And it works really similar. Works really similar. And it has embedded with Fusion and Inventor, and it's a cross-platform between Autodesk. What happened? All the development of this tool is only based on Autodesk. It doesn't have like millions of users that actually are writing plugins for it. So actually, it's as good as Grasshopper. Yes, has some pros and some cons, like all the programs. But it's missing like the millions of users and the community actually writing plugins for it. So that's why not a lot of people use Dynamo, because they already create a community that makes good plugins and they already exist. They don't need to move all the plugins and utilities to another program. Okay. In general, did that solve the question of what parameterization?
Definitely,
Yep.
yeah.
Okay. Like examples like this are super clear. For example, example that is not architecture. For example, you see this shape. This is customized. Basically, it's an extruder for plastic, for ceramic printing. This is what they use in the OTF program, the Open Test Fabrication, to actually extrude on the machine with clay so they can test the small prototypes. We have changed this design like, I don't know, like 50 times. The whole of the inside is 8 millimeters, but sometimes needs to be 8.005, 8.05, because we are 3D printing. The tolerance changes. So instead of designing this in Rhino and have it to modify every time and make a new model out of it, we have this modeled completely in Grasshopper. So if we want to change the size of the screw, we just change a number in a slider in 1 second, and we have already the updated model. So we don't lose like half an hour every time we want to change something about this design.
Right, that makes a lot of sense.
That said, like not always making everything parametric is what you should do. Like there are some things that are so easy and get so complicated to do in Grasshopper that doesn't deserve the time. Why? Because maybe it's something that you just want to do it once. Second, to allow you to produce these kind of things, you need to find the logic behind it. So in this case, this example is way easy, like so easy. It's an array of boxes located, and each one has different height. So to produce this geometry, you can do it in several ways. First, we produce an array, and then we move the objects into each dots of the array. Or you produce the box, and then you move them into an array. Or you can produce a box and move it 10 millimeters, 20 millimeters, 30 millimeters, 40 millimeters, 50 millimeters. There is a lot of ways of producing this geometry, but you need to find the logic. And how you find the logic? Trying to go to the simplest component as possible. So, sorry, something I want to explain with this is here, in the moment we have an array, if we connect a panel, what we have here? A list of boxes, no? Actually, too many boxes. I'm going to reduce it. First, I'm gonna connect, I wanna have a square array, so I will connect both at the same place, and I want to have like 12. So now I have like, how many boxes? 144 boxes. Let's say I want to choose one of them. All my data is together. It means all the boxes are in just one location. So I can just take, for example, number 10 and number 20 and number 30. We can select only a few ones. We can select only the first one. We can select the last one. And that is important because it's the same as we have here, but in a simplified way. What we are doing here with this component is listing them, making a list out of different components. So we have 3 independent components. We make a list, and with the list of points, we produce a polyline. I'm gonna switch off this. I have selected this too. Okay, thank you. Okay, I will move this and I will switch it off. So here I have a list, and depends on the order that I connect my points, they're gonna be in a different way. So there are some tools that help us to know which point is which one. One will be point list. So we connect, and now we can see some numbers, but they are really small. This component, what it's doing is saying which number is each one. Let's change the size. When you hover over the components, they always tell you a reference guide of what is each letter states for. So I'm going to change the number by 5, for example. Now I can see point number 0 is the first one, that is 0, 30, 36. How I know it's 0, 30, 36? Because look, if I change the coordinate, it changes with me. It's connected the first one. The second one is the reference point. It's the point that is drawn in Rhino. And the last one is this middle one. Okay, to make it clear, let's connect the first one, the second one, and the third one. So it's a little bit clear. So now the order of points changed. Polyline component, for example, show us an option. See, this, actually the component is working without any fuss, without having anything connected here. A lot of components have optional things to activate or deactivate. So when you produce a polyline out of, for example, 3 points, we can close a polyline. So a closed polyline will be 0, 1, 2, and connection from 2 to 0 will be closed. How we can activate this? This symbol means Boolean. Does anybody know what is a Boolean? Boolean?
And
Okay.
or
A Boolean is basically how it's binary. It's how computers speak. To make it simple, is 0 and 1. You know that computers have 0 when it's open, 1 when it's closed. Actually, it's the opposite. Sorry, it's 0 when it's closed, 1 when it's open. So we can state Boolean, and we say Boolean toggle. That is false or true. If we put a panel, we can see the false is 0, false is 0, true is 1. A false in Grasshopper is the same as this. And a true is the same as 1. So if I connect this toggle here, I want it to be closed. False, no. I want it to be closed, yes. So this is a button to activate and deactivate things. But this is called Boolean toggle. The Boolean that we are producing is a 0 or a 1. For example, right now this is 0, but if I connect a 1, it will produce the same effect. Because in Grasshopper, true is 1 and false is 0. It's binary. Did your brain exploded or not yet?
No, that actually makes sense.
Yeah, it makes sense, but sometimes takes a little bit of, like, it's kind of a language that people usually is not used to. But you will see that in coding, this will be your daily life in the rest of the code clubs. So
this is just a situation where you're basically just flipping a switch. Yes.
Exactly.
Yeah.
But it's important to understand that this is not a false, like you are not inputting a name here. You are inputting a 0, but you are doing in a graphic way because sometimes this toggle, you want to do it automatic. For example, let's make a condition. And you always want to have everything as automatic as possible. For example, if the list that I'm producing is higher than 2, it means I have more than 2 points, I want that my polyline is closed. If I have only 2 points, I don't want it closed. Why? Because closing a polyline that is between just 2 points is the same line itself, no? You don't want to close a polyline that is made out of just, let's say, if I disconnect this, oh, why is not disconnecting? Yeah, of 2 points. You don't want, it's the same line itself. You will not see any difference. So, for example, if I have more than 3 points, it is higher than, larger than. What is larger than? The amount of points. How we measure, how we know the amount of points? List length. So we want to know the amount of points that we have. If 3 is larger than 2, true. What is a true? It's a condition. It's true, so yes. If we just erase this point, this will change, for example, automatically. It will be like automatic trigger. False. It will not make a closed polyline, but because I just erased 1 point, because we have 2 and it's not larger than 2, so it's not working. So now, in the moment I have more than 2 points, still work. Let's say I want that is larger than 3. So now I have only 3 points. Let's say what happens if I connect, when I make another one, construct point. I connect, in the moment I have 4, it's close point. And now it's a little bit confusing because it's in the middle of everything. So in the moment I have 4 points, it will be closed. In the moment I have 3, it will be open. I just established a condition. Based on what? On the total amount of points that I have. Yes?
In real life, would you be doing this list length larger than equation?
This, actually, most of the things you do in Grasshopper is making rules like that.
Oh, wow. Okay.
But you do it in a more complex way. This case is really useless because this is 4 points. This is just 4 points. But it's important to understand this because we will do it next time. I want to introduce you another thing. I'm not gonna erase these kind of things. I'm just gonna make a copy. I'm gonna move everything down. And let's switch off everything. Okay. Let's construct a point. We have made 3 points, one before. one by referencing, one by constructing a point with a slider and a panel, and just with the sliders. Let's say we want to create a lot of points. Like we don't want to create just 3 points. We want to create 100 points. Each one is spaced certain amount. Do I need to create copy tons of these guys? No. We can automatize it and create points from datasets. What is a dataset? Something that is really important to, where is this sequence? Yeah, here in sets is how to produce multiple numbers at the same time. We know that we can create numbers with panels, for example. We can create with sliders. What happens? We want to create like 20 numbers. Let's say I want to create a point that is in 0 and a point that is in 50 in X. You can do this and you can do this, no? We have learned that we can connect multiple things in one component. Sorry, let's disconnect. I will put a panel here so we can actually see it. Can connect it to here and can connect it to here. In just one component, I have created 2 points. So we can feed multiple data all the time to all the components. So it's like producing duplicates of it. This is the same as having this. This produces the same result as this. The difference is we are using less component and everything is automatically already in one list. We don't need to put it together. So how we can do this? Let me explain. This and this is the same. How we can do this in a clever way? We can create, what is this? This is one number and this is another number, no? This is a series of numbers. What we can do is use a component that is called series. Series of numbers. Instead of using this, let's switch off again to, I will use this one. Construct point. This is off, now it's on. So this series is producing something. What is the first point of the series? Let's put a panel to see the exit, the amount of data. So it's producing first number in the series. The first number is 0. The step size is the spacing between the different numbers. The spacing for each number is 1. It's growing 1 by 1. And count. How many numbers do we want? You say here it says 10. How many numbers we have in the output? It's an open question. We have 10 numbers. But remember, in coding and mathematics, the first number is not 1. The first number is always 0. 0 counts. 0 exists. So we have first number, and we want to create 10 numbers, we actually go from 0 to 9. It's really important to remember that. So let's say we want to have only 5 numbers. Look, I already can change easily the amount of numbers that I want. Or I will just want to create 2 numbers. And before, here I said that the second number I want to be at 50 of space. So I can, the step size is 50. So now I can create a series of numbers that they are all spaced by 50. And maybe the first number I want that is also 50. So my list starts in 50, 100, 150, 200, 250, 300, 350, 400. So I have a list of numbers that I can easily connect to construct, and I will have a list of points. Yes? No?
Yes.
Okay. The same as we have series. In series, we control the amount of numbers that we have and the spacing, but we don't control the higher and lower limit. But you control it, but it's more difficult. You need to make a multiplication. 50 by 80 plus 50. What happens when you know that the maximum limit is 200 and the minimum is 0? It means you want to create a list between 0 and 300. Exactly. Here you can do it by changing the slider and just checking manually. But what we can do is we can create a range. So we can control more the values. In this case, the range is in a domain. What is the domain? From 0 to 1. I want to create the numbers from 0 to 1. And I want to have how many numbers? The steps. 10 steps. Because 10 steps is not 10 numbers. It's actually 10 breaker points. You need to always remember that. This is the biggest difference between count and steps. If you click to have, let's make it simple, 10 numbers, you will have 10 numbers, is from 0 to 9, but in a range, steps is number of steps. It means breaker point, spacing. We don't have from 0 to 9, that is in this case is from 0.09 because it's 0 to 1, but we have also included 1, is a higher limit. How we establish the domain? We need to construct a domain. Construct domain is like a higher and lower limit. So we want it to be from 0 to, for example, 1. Or maybe to 10 in this case. So it changes actually something. 10. So we are constructing a range. It means we know that the lower limit is fixed and the higher limit is fixed. Let's say we want to only create 5 steps. I have created a spacing. It's the same as establishing what is the mean, sorry, my writing, and the maximum. You can either divide this into 3, or you can either divide this spacing between 200. You still will have the same fixed values, min and max. Meanwhile, in series components, what we establish is the minimum value, the step dimension, and the amount of times. The amount, number of times that you do the spacing. You understand the difference between series and range? So there are 2 control ways of actually constructing points. But still they both work in the same order. Ooh, what happened here? And this is funny. I think I will leave this for next class because tomorrow it's going to be too messed up if we explain it today already. So we can create a series of spacing to produce different numbers. Let's say that we want that this is a curve. We can produce the same, or we can, for example, make another rule. Today is like showing up a little bit of tooling. We are not producing any geometry. Next class is going to be on really producing geometries. Let's go to mathematics. We want that the y is squared of the x values. So this is going to give what kind of shape? is a exponential, because the xy values grows as twice as fast as the x ones. Or we can produce a square or cube roots, etc. But the point here really doesn't matter. If we connect both at the same time, it's going to be a perfect diagonal all the time. And actually, it doesn't matter the length. It's always going to be a perfect diagonal because the x and y values grow evenly. What we can do with this? We can create a line. What a line is produced by 2 points, a polyline is produced by multiple points. Polyline. So actually we just produce that polyline, and this is, for example, a way to produce a polyline. In here, it actually doesn't make too much sense to have it like this, because we can produce it just by 2 points. We know the highest and the lowest value. But in case that, for example, it's not a straightforward rule like this one, it's a square, it makes sense because the growth is different. And what we can do is just don't visualize the points and just visualize the polyline. That is what we want. Or I don't know, we can power of 10, multiply by 10, whatever. Like really it doesn't matter. We can also produce a cosine to actually produce a wavy factor. I think it's sine, not cosine, to actually produce it. It needs to be between 0 and 1, 2, yeah. So by a cosine, what you will do is, depends on the scale, but you produce a wavy pattern. And there are points. How we can make this one smoother? Instead of producing a polyline, we can create a curve. What is a way to create a curve? Interpolate data. That is, interpolate points to create a curve. That is the same as spline. In Grasshopper, it's not called spline, it's called interpolation. And just like that, we just produced a wave that could be as short or as long as we want, with more or less spacing. Yes? No?
Interesting.
I know today is a little bit confusing. It's the first day, and most of you have never touched Grasshopper. But we went through the basics on how to put components, how to look for them, visualization, enable or baking, how to combine to create multiple things. We went a little bit hard in the moment we created the Molo Custom Museum here, but this is how we basically create all kinds of things. And we explain at the super basic sets. So next class is in 2 weeks. Yeah, next one is code, and the next one is again Make Club, and it's gonna be continuing on this work. So my recommendation is read. Well, first, I want to be really clear. Grasshopper is impossible to learn just by watching. Like, you can watch as many tutorials of Grasshopper as you want. If you don't go your hands on and start putting components and try to make them work, you will never, ever learn any kind of Grasshopper scripting. It's not theoretical knowledge, it's something that you gain by experience and by getting used to. I would say that this is basic to understand it. So I recommend you that start trying to put some components. For that, I will put in the link, I will send you in 1 hour or two after lunch, some basic scripts that are those ones that we're going to work on to next sessions, all these ones. And they have the basic of Grasshopper, how to create simple geometries. I don't expect that you understand how all of them work, okay? This is a tooling class, but in order to learn them, for example, this is how to create, for example, this kind of pipes, how to create simple lines. It's a little bit of what we just did today, but with different kinds of patterns, how to create different kinds of lines. All explain it by series, by points, by curve,
Will you
etc.
post this
Sorry?
in the drive? Sorry, will you post this in the drive or in the...
I will put it in the repo that we always have. That is here. The link that I sent you of the Grasshopper classes. Clubs, make clubs, Grasshopper class. I will reorder this to be the first one, and I will put all these files. Okay? Right now, these ones are like more advanced. I will create one like intro Grasshopper, intro. So I will put these files, and I recommend you that you try to go over them. Even if you don't have too much time, that probably that happen. At least start reading a little bit of this. So in next class we can go slightly faster and start producing geometries quite fast. Okay.
Could you send us that link, Edu? Or is that also in the...
Chat. Yeah. For the ones that doesn't have Grasshopper, please try to have it installed before next session. I think you have enough time, 2 weeks. So this is a really simplified guide, like that basically states the foundation. For example, what is the blocks, data types, like wiring, how to connect the wiring. So basically all what we just went today, simplified, explained with words and images. Okay. So it's basically it's a cheat sheet document on to like little tricks to disconnect blocks, because sometimes you forget, okay, which key I need to press to actually disconnect the wire or to connect multiple wires at a time. So for example, chapter number 1.5 is really too much. I would recommend to go through all until 1.3. 1.2, 1.3 is enough for the next class. That's my recommendation if you want to actually go faster, to produce clearly like faster geometries that we can play with. If not, we will take more time to produce everything. For example, animation from finding photogrammetry Galapagos, from finding truss, day 3, animation, structure,
So we're gonna go faster next class than this.
Yeah, exactly.
Okay, just clarifying.
Let me see. This is camera bending. We don't want to do this. Animation for finding. I'm trying to look for one example to try to.
Until 1.3, Edu?
Yes.
In ModeLab, 1.3 till next week.
Well, next week, 2 weeks.
Yeah, 2 weeks until 1.3. No, building blocks of algorithms.
Yes, exactly. So it's basically points, planes, how to understand. It's basic geometry concept, but as the way on how to interact with them changed a lot in Grasshopper, and initially you will say that, okay, this guy is explaining me like, okay, it's a vector. What is a vector? But this is really important to have clear the idea of vectors to really understand what we are doing. And the way how to construct them works slightly different in Grasshopper. But for example, you see this base. This base is basically the components that we use today, but just by this you can produce like tons of a catalog of millions of bases. just by changing this graph. One, we have this script designed, and this script, it has like, I don't know, 15 components. But in order to make it work, you need to understand that we are working with a list. That list needs to be constrained, has a top and a maximum. What is multiplication, scaling, rotate? When you rotate, you always rotate with a plane. You have a plane of rotation, etc. So we will work still with ultra basic geometrical concepts, but we work with vectors, we work with planes, we work with data lists. That is something that you usually don't play with when you are drawing literally this in Rhino or Fusion or whatever tool for designing you use. Okay? Just to give you and to try to show you something that you might like. For example, things that you can do with Grasshopper. Where is this? I did a few years ago. Okay, this is full Grasshopper. Okay, this is the animation and everything is also done in Grasshopper automatic. So basically, it's designing some forces with some physics plugin of Grasshopper, and you are launching kites, and it's behaving with the wing that is randomly created in Grasshopper. What is wing, for example? Wing is a vector. It's a vector with a direction and a strength, that is the length of the vector. So if you know how to create millions of vectors that are constantly changing, you can simulate wind. So in this case, it's automatized that you only need to create 2-3 lines and play automatically the Grasshopper script, and it will always update it and produce another animation.
Sorry, Edu, what was the name of that program?
This is Grasshopper.
But the rendering, all that is as well Grasshopper?
It's all Grasshopper.
And the animation?
All Grasshopper.
Wow, great.
No, you only use Grasshopper. This is only using Grasshopper.
Right.
What you use is a plugin to help you with the with the physics, but it's a physics engine for Grasshopper.
Okay.
You set up like force, like gravity, and these kind of things. For example, this is recursive algorithms that create more and more spaces in a random way. Creating this by hand is impossible, so this is when Grasshopper makes sense to use it. This is just a glimpse. You can do the same with structural analysis, water, for example, wind simulation. There is a plugin that is awesome for wind simulation that is called Wind Simulation Flexhopper Grasshopper. Like, by the way, all the plugins of Grasshopper are called by animals or like animals. Do we see the video here? Or things like this, that is particle analysis, like for example, how the water flows in a container. You can also do it in Grasshopper. And basically, why? Because this is millions of dots that are moving in vector direction. And the only way how to work with this kind of amount of data is to parameterization. This plugin is not easy to work, and we will go through this at the end of the course, but still we will go through it. But to reach that point, we need to first understand the basic sets. So before running, we need to learn how to work. Okay, someone is speaking in the chat. Okay, and that's it for today. I think it's enough, no?
Yeah, thanks.
I hope you enjoyed, and well, see you in the next Code Club. That is next Monday, same hour.
Thank you, Edu.
See you
See
then.
you.
Thank you, Edu. Ciao.
Bye bye.
Bye bye. Thank you.
So much.
Bye.